Welcome to this question on geometry problem solving, as I've called it, because it involves half circles, areas, circumferences, and Pythagoras theorem. Okay. On a question like this, it usually carries several marks, probably 5 or 6 marks for this. Read all the information carefully and make sure you form a strategy to solve it and make that clear in your working. You must show all your working. You can't solve a problem like this without writing quite a lot of stuff down. The diagram shows the plan of a new outdoor seating area space for a cafe in a park. The meadow and pond are semicircles, and the seating area is in the shape of a right-angled triangle. Low wooden fencing surrounds the pond, the meadow, and the seating area as shown. So basically you can assume all the lines drawn on the diagram are fences. Calculate the cost of the fencing required. Okay, well, before we can do that, we need the length of the fencing required. So let's put some missing information in. Okay, so I'm going to label the length of the long side of the fence along the seating area as X. I'll call this length around the pond Y. So this is the arc or the semicircle length of fencing around the side of the pond, and we'll use Z for the same for the meadow. Okay, so it's that length around there. Okay, and I can make a statement, and you should do this early on. So total fence, so this is question A. Okay, total fence is going to be made of 5 bits, 5 sections. Okay, and it's going to be the 7 and the 12. Okay, it's going to be the X, it's going to be the Y, and it's going to be Z, all added together. And that's a statement of intention. It's showing what you are going to work out and that you understand the problem. Now, we'll just do a little box over here where we'll show some separate working for that information. So if I just box off a little bit here. Okay, I'm not saying you need to do it like this in the real thing, but it makes it clearer what I'm doing here. So I'm going to say that let's find X first of all. Well, X is the hypotenuse of a right-angled triangle. Okay, and because it's the long side, it's given by the square root of 7 squared plus 12 squared. Okay, now if you work that out, it's the square root of 49 plus 144, and that of course is the square root of 193. Okay, and leave it like that. Do not decimalize it or try and round it. It's exact like that. Keep it like that for now, and let's work with that number. So what about Y then? Well, Y is half a circle, half of the circumference of a circle of diameter X. Okay, and you should know that the circumference of a circle is pi times the diameter. But we've got half a circle, so it's a half of pi times the diameter, and we've just worked the diameter out. It's X, which is root 193. Okay, and again, we'll leave it like that. We don't need to know the numerical value of that. We just need to use it in a minute in that form. And we also have Z, and Z is the same sort of thing we've just done, except for the slightly smaller semicircle, which has a diameter of 12. Okay, now half of pi times 12 can be simplified to 6 pi, and I would do that in this case here, 6 pi. Okay, so we now have the value of X, the value of Y, and the value of Z, and we need to substitute them into here to work this out. So the total fence is going to equal 7 plus 12, okay, plus root 193, okay, plus half of pi, or pi by 2, times root 193, plus 6 pi. You must write all this down as well as put it into the calculator. Okay, and if you work that out, it will the calculator will give it to you as 73.56. Okay, 73.56419, etc. So give it plenty of accuracy. The calculator will keep things in natural and exact form as far as possible, but once you go to something which involves square rooting something and then a factor of pi, it will decimalize it, and at that point you can do the same, but far more accurately than you need it to be. All right. So I now know the total length of the fencing. Now it says here that the fencing comes in 3-meter sections. Now, if I do 73, so now I want the number of sections of fencing. So 73.564, and divide that by 3. Okay, now I can probably see the answer is going to be that I need 25 sections of fencing, but I'm just going to show that it's 24 point something. Okay, let's just actually do what it is. Okay, 24.52. Okay, and then what I'm going to say is therefore 25 lengths needed, 25 by 3-meter lengths needed. Okay, so I've even shown how I've come to that conclusion. Okay, so 25 lengths needed, and then I need 25 times 95 pounds. Okay, 25 times 95, because each section costs 95 pounds, you see. Okay, and if I put that on the calculator, 25 times 95 gives me 2375. Okay, so that equals 2375. Okay, and that is total cost, or cost of fencing. Okay, and it's very clear from all of that that you knew exactly what you were doing and that you've arrived at the answer with a logical and clear process. Okay, now we have to calculate the area of the pond and give the answer to 3 significant figures. Okay, well, the area of the pond, if I do that down here, it doesn't take up much working. So the area of the pond is going to be half of pi r squared. Okay, half, I'm just putting it like this, half of pi times r squared. Now, the radius of the pond is half of root 193. Okay, so it's root 193 over 2. Okay, root 193 over 2 squared. Okay, now if you square something with a root in it, you see you cancel the square root out, so you get, and then there's the 2, and this 2 has to be squared as well because it's inside the bracket, so it's a half of pi times 193 over 4, which is 193 over 8 pi. or 193 pi over 8. That's exact, you see. That's the exact answer. Okay? And then you can just say that that equals, on the calculator, that comes to 75.79, which is 75.8 meters squared to 3 significant figures, which is what you were required to give. Okay, and that is the answer to the area of the pond, which was the second part of the question that you had to do. Okay, so we have the total cost of the fence needed, with clear steps shown, a bit of working out here, all the detail necessary to show that you understand the problem. And the second part here, recognizing that the radius is half the diameter, okay, but using the exact values all the way through until the end. Okay, you see, if you rounded something here too early on, it's quite possible that when you got this to this point here, you might have ended up with, say, 75.7 or 75.9, and then you would have lost the accuracy mark, because the true answer to 3 significant figures is 75.8. So don't take the risk of rounding things off earlier on before you need to. Okay, I hope that was helpful. Take care.